Thank you to everyone for joining us today, especially our partners at NHN for hosting this event. We're delighted to be formally recognizing the special working relationship that our two companies have built and look forward to the many projects that we'll be undertaking together. NHN is an enabler of the future, developing critical AI infrastructure that will ensure Korea's place as a world leader in this emerging field, which is so full of opportunity. We're thrilled that they have chosen to work with Graphcore, recognizing that our technology will help bring that future forward faster. When my co-founder Simon Knowles and I decided to start developing a microprocessor specifically designed for artificial intelligence, we didn't know precisely what the AI world was going to look like when the chip was ready. Models would almost certainly have changed, and the potential applications would have evolved too. Fortunately, not knowing precisely what the future holds is sometimes a good thing. It forced us to develop an architecture that satisfied those requirements of AI that could be foreseen with a good degree of certainty, like the importance of graph, the need for large-scale, fine-grained parallelism, and a number of other characteristics. But it also compelled us to build a processor that was flexible and generalizable, ready for AI applications that hadn't yet been invented. Both Simon and I were conscious that AI researchers at that time were suffering from a common problem. Like many innovators, the tools available to them were limiting the scope of their invention. As the saying goes, if all you have is a hammer, everything tends to look like a nail. Processors like the CPU and GPU seem to be doing a good job moving artificial intelligence forward, but look closer, and you would see that new developments were tending to reflect the capabilities of these devices, rather than the much broader possibilities that are incumbent in AI. The Graphcore IPU lets you paint with a broader palette, to imagine something more than what is already possible. The sheer power of our processor is already outpacing other types of compute systems on today's most widely used workloads, but it's the IPU's ability to unlock new directions in AI that is proving particularly attractive. One of our customers, Tractable, which provides accident repair estimates on photos uploaded from a driver's smartphone, recently revealed that the IPU has given them a 5x speedup compared to the GPU systems they were previously using. Tractable employs the most advanced computer vision models available today and is constantly developing more sophisticated versions of its technology. Working at the cutting edge like that is hugely computationally demanding, but with the IPU, Tractable can now perform tasks like training runs that would have taken 5 days. They're now done in a single day. Graphcore technology allows innovators to explore these new opportunities. In that sense, we're very similar to NHN. Your company has changed a great deal over its lifetime, growing from gaming into financial technology, cloud computing, and many more areas. Every time you're responding to an emerging need and also creating new opportunities for others. Nowhere is that more obvious in the construction of AI data centers that will underpin the country's next phase of economic and social development. That spirit of consciously creating new opportunities is the foundation that modern Korea rests on. The success story we know today didn't happen by accident. It was first imagined, then built. You understand what it means to start with a blank sheet of paper and say, how do we equip ourselves for the challenges that lie ahead? There's a great expression used in the Korean government's AI strategy. They call this the fourth industrial revolution. The thing about industrial revolutions is they are associated with the development of new tools, weaving machines, the steam engine, the transistor. Today, it's Graphcore and NHN putting new tools into the hands of innovators. The things they will do are incredible. I look through the world at breakthroughs already being achieved using GraphCore systems. The Oxford Man Institute, part of the giant Man Group, has developed an AI that can predict stock price movements further into the future than previously possible and with greater accuracy. In France, cosmologist Bastien Archelin is using the IPU to process images taken from deep space telescopes, extracting individual images of overlapping galaxies. Researchers from the Ford Motor Company used GraphCore technology to help them design future pedestrian detection for autonomous vehicles. And closer to home, KT, Korea Telecom, will also be using IPU compute in its AI data center projects. Amazing things happen when you put this technology into people's hands. And both NHN and GraphCore want to ensure that the very best AI tools are widely available and easy to use. Despite the importance of our hardware, the truth is that most people who use our systems will never actually see an IPU processor or the IPU pod data center racks. What they'll come into contact with is our software, which we call Poplar. The sophistication of the Poplar software stack today reflects maturity of GraphCore overall. It includes our own graph programming framework and comprehensive open source PopLibs libraries. It also offers seamless compatibility with the frameworks that people use, such as TensorFlow, PyTorch, PaddlePaddle, and more. And if you want to bring an existing model to the IPU and just plug it in, you can. Poplar manages countless other functions, from compiled compute to scale out for larger models. Our PopVision analysis tools make it easy to see the optimized workload distribution on individual IPUs, while industry standard deployment and system management tools ensure that GraphCore systems can fit into any mixed-use data center. This may be the first industrial revolution to offer a truly seamless transition from the past into the future. And on the subject of the future, it's worth us taking a moment to look ahead together to what comes next in artificial intelligence and its implications for compute. Model sizes have grown exponentially. GPT-3 hit the headlines worldwide, not just because of its amazing potential, but its phenomenal 175 billion parameters. With the growth of unsupervised learning, model sizes will continue to grow. However, this is computationally unsustainable if we continue with dense models, which effectively process far more of the model than is strictly necessary to solve the specific problem. Research by Google Brain on trillion parameter and larger models, as well as numerous other AI researchers, has shown that sparse computation is the only way to resolve this problem and continue our current rate of progress. This sparse approach is able to focus just on those parts of the model relevant to the problem being addressed. The dense model is like every neuron in your brain firing just to process an image coming through your eye. The sparse approach is similar to using just the neural pathway that looks after image processing. The ability to perform sparse computation is one of the capabilities that we designed into the IPU. This and other forthcoming developments in AI will justify the choices we make in creating the IPU, while at the same time will test legacy processors to their limits. We thank NHN for sharing that foresight and the vision to empower others to innovate with our combined technologies. The future that began with imagining what was possible is now being built. Thank you.